Okay, so this is 1, 2, 3 matrix multiplication. So now for matrix multiplication, we have it is multiplication of a matrix by another matrix, and in this case, if you have A times B, and if it gives a matrix, this means that A and B are conformable uh, in accordance with the multiplication, matrix multiplication. Okay, we start by this learning activity. So here we have two friends, Agnes, symbolized by A, and Betty, symbolized by B. They can buy sugar, rice, and beans. In this case, let me choose a good marker pen. So they can buy these three items, sugar, rice, and beans, at one or two supermarket. Suppose the first one S1 and the second S2. And suppose that a matrix here, M, showing the number of kilograms of each of the three items bought by each friend, either Agnes or Betty, to the respective supermarkets. Okay. Now another matrix B, it is showing, so the matrix M, for example, if we consider S1 and S2 for the first supermarket, 132 and 24, in the okay, now no, let us now suppose not the S1 here. In this case it is not S1, it is not the supermarket here. Rather it is the kilograms bought by Agnes here and Betty here. So Agnes bought 1 kilo, 1 kilo for sugar, 3 kilos of rice, and 2 kilos of beans. So Betty bought 2 kilos of sugar, 4 kilos of rice, and 3 kilos of beans at one or at the two supermarkets, for example. In this case, another matrix P, it is showing now the price at the first supermarket and at the second supermarket, for example. This is the price for the first supermarket, and this is the price for the second supermarket. Now, the prices are given in 100 francs, or 100 francs. So for respectively in the different, as we are taught, respectively. Okay, now first question: compare the number of columns of the first matrix M to the number of rows of the number of rows column for the first one, number of rows for the second matrix B. B, calculate the shopping bill. The bill for each of the of the supermarkets, for each person, A and B, Agnes and Betty. Now, C. So here, to B, express the answer as a third matrix. Suppose C. Now, how many rows and how many columns does C have, for example? Now, D, use matrix M and P to explain how each entry of C is obtained. Okay, now let us answer this question. Answer to this answer or solution to or learning activity. 1, 2, 3. Okay. So now here, so we can compare number of rows and the number of columns. The first comparison. So M, how many number of rows, number of columns for M? We have 1, 2, 3, 3 columns. So matrix P has how many rows has it? P has 3 rows. And then subquestion B. So calculate the shopping bill of each of the two supermarkets. Suppose let us calculate the bill for Agnes, for example. In the first supermarket, so for Agnes, he bought 1 kilogram of rice, 1 kilogram of rice, and at a price, suppose in the first supermarket, let us suppose in the first supermarket S1, so he bought 1 kilogram. So bid at S1 for Agnes. So bid for Agnes. So in the first supermarket, he bought 1 kilogram at of sugar. It is of sugar, not rice. So in the first supermarket, we have 1,800 London francs. We're going to multiply by 1 kilo. In the first supermarket, 1 kilo of sugar, and for the now number of kilos of rice, we have 3. So at the price first supermarket, so we have 2,000 or 2,500 times 3 kilos of sugar. Now plus now 1,500 now times the number of kilos for beans. We have 2. Okay, in this case it is in Rwandan francs. So now the bill is 1,800. 25 times 3, it is 7,500. 15 times 2, it is 3,000. Okay, 3,000. And summing up, we have now 10, 100, 105. So 10,000 and 500. So we are going to add 2. So 7,500 plus 3,000. So this is the 100 and 500. So it is 10,000 and 500 Rwandan francs. So to add to it, we have to add 118. So 1,800 we add here in order to obtain. I carry 1 and this becomes 2, and I have 12,300 Rwandan francs. Okay, now here let me take another marker pen here. Okay, so now this is the bill of Agnes. Bill of Agnes. This is bill of Agnes at the first supermarket. Okay. Now in this case, this is the bill, and it is this one at the first supermarket. At the second supermarket, now let us calculate the bill of Agnes. Bill of Agnes at the second supermarket. So this will be, so still we have 1 kilo of rice for Agnes, of rice, no, of sugar. So now we have to multiply by the price at the second supermarket. It is 1600. So we have to multiply by 1. So adding 2. Now for now rice, we have 3 times the price, 2000 times 3. Adding 2, we're going to add 2, 1200 times 2 here for beans. So this is 1600 plus the 6000 plus the now 2400. Okay, so now let us now add this. This is the bill of Agnes at the second supermarket. So it is 1600. We add that 6000. Oh, no, that is 6000. 6000. 6000 coming from 2000 times 3 is 60,000. 60,000. Okay, now adding up to 2400. So this is going to make now 10,000. This is 10,000. We use this color, this meaning this marker pen. So summing up to 10,000. Okay, Rwandan francs. Rwandan francs. To this is the bill at the second supermarket for Agnes. Okay. Now, in a similar manner, so we are going to calculate. In a similar manner, we are going to calculate now the bill for now the second person. Bill for the second person, Betty. So for Betty, so we are going to calculate bill for Betty. Bill for Betty, we have a bill for the first supermarket. So bill for the Betty for the first supermarket is going to be equal. It is the same price per kilo. Price per kilo of sugar. So this one bought 2 kilos. The second person Betty plus price for no rice is 2,2500. So times the number of units of kilos that Betty bought has to buy. Now here times 1, so 1500 times 3. Okay, so this is 3600. plus this is 100, it is 10,000. So plus 10,000, yes. Now plus 30,000. Okay. No, 45. Sorry, this is 45. 15 times this 3, 45,000. Now, summing up what we should have, we should have now here uh, the calculations like this. So I take 3600, so 10,000, 10,000 and 4,500, 4,500. Okay, so what I have adding up 1, I carry 1 and I have 8, I have 1. Okay, so now this it seems that this is what we have for Betty. This is the price of 18,100 francs for Betty. B for Betty in the first supermarket. Now, what about the second supermarket? B for Betty for the second supermarket. So, still we have 2 kilos of sugar, 4 kilos of rice, and 3 kilos of beans. Now, price for the second supermarket 1,600, 2,000 for the second supermarket, and 1,200. Okay, now product is 3,200 plus 8,000 plus 3,600. Now adding up 3,200, 8,000. Now 3,600 adding up. Now we have situation here 8, and then this is 14,800 in this case. Okay, so now this is B for Betty in the second supermarket, 14,800 Rwandan francs. This is the bill for now Betty. Now that is subquestion B. Subquestion B, answer of it is this bill. Now, next, what do we have to do? Let us continue with expressing these results as a matrix C, for example. What if it were a matrix? What will happen? Okay. So now subquestion C, let us answer. No, before we move to subquestion C, let us see obtain the matrix. Matrix we have, so it will have the following structure. We will put the bill. So it will be a bill price. So the bill actually, this is the bill for Agnes, and for suppose let us look at for Betty. So in the first supermarket and in the second supermarket. So in the first supermarket, Agnes had 12 first supermarket 1200, 12,300 and things, and in the second supermarket 10,000. That is for Agnes. Now we should be here 10,000. 10,000. Okay. What about Betty? Betty has now for Betty we have 18,100 drinks in the first supermarket. In the second supermarket you have 14,800 drinks. That is how the B matrix. The C is actually a B matrix for the first column for the first supermarket, second column for the second supermarket. Okay, that is how the matrix C will look like. Okay, so now sub question C. We are ready now to move to sub question C. Here can remove this part in order to answer sub question C. Okay, so in this case, the question is how many rows and how many columns does C have? Okay, this is the sub question C, the B matrix. C has it is a 2 by 2 matrix. 2 by 2 matrix. This is a 2 by 2 matrix. It means that it has 2 rows. So how many rows? 2 rows and 2 columns. 2 columns. Okay. Now this is what the matrix C is looking like. Now we move to sub question D now. Use the matrix M and P to explaining how each of its entries is obtained. Okay. Now let us look at how this one was obtained. Okay. So now the first component was the rows of the matrix M, rows of M, we multiply by columns of matrix P in order to find entries of matrix C, B matrix. This is how matrix C were obtained. And actually this is how the matrix multiplication is working. So you take rows of M, you multiply by columns of the second matrix M, the first matrix, P, second matrix, in order to get entries of matrix C. In other words, this is how multiplication is made. It means so matrix P. We are going to remember how to look like. So actually this was a matrix multiplication. So it means that if we were to multiply matrix A times B, so the product is another matrix. In case suppose you have this was the matrix. Actually, here it was not A matrix. The first matrix was M, and the second was P. So in this case, we had matrix M, matrix M, if we remember, matrix M. So it has the first row 1, 3, 2, 1, 3, 2, and the second row was for M was the second one. No, wait. The second one was let us see. The second one was for Betty was 2, 4, 3. 2, 4, 4, 3. Okay. Now, how about matrix P? So matrix P was so 18, 18, then 25, then 1500, 1800, 1800, so 2500, then 1500. First column, second column we have to look 116, 1600, 2000, 2000, and then last 1200. Okay, this was the matrix P. So that how many rows, how many columns of the first? So we had this was matrix M was matrix M is 2 by 3, 2 by 3, or I can write it like this. Second matrix P was 3 by 2, 3 by 2, and the result was is 2 by 2. So actually, this is how matrix multiplication works. It means that in general, if we have a matrix A times B, giving matrix C, suppose you have matrix M by P and Q by N, second matrix. In order to produce this matrix C, it must have a size M by M by N in this case, but provided P is equal to Q, otherwise the product is not possible. So it will be possible when the number of column P is number of columns of the first matrix, and Q is number of rows of the second matrix. And this multiplication is conformable relative to the product AB, which must produce a third matrix C. Okay, so this we have come to the end of this video, which was about the learning activity 1, 2, 3. Okay, so thank you very much for watching.